ethers. And ether is a hydrocarbon that contains an ether group. I was kidding. It contains an oxygen atom embedded in the middle of a hydrocarbon chain. Don't draw this yet, but pretty much it looks like this. An O in the middle, and then we have some C chains flanking it. Now, because this oxygen has two lone pairs like this, from our VSEPR theory, we know that the ether molecule is not a linear molecule, but rather it is bent. So it's more accurate to say, or to draw ethers like this. So here is a very simple ether. I'm going to draw like this, with the lone pairs showing, just to remind you that there is a 3D structure to it. Now, even though the oxygen atom is rather in the middle, slightly in the middle, the ether molecule is polar because of this bent structure. The polarity goes towards the oxygen, so you can imagine a dipole arrow going upwards towards the O like this. The bent structure is not a terribly steep or a pointy kind of bend. It's a little shallow. It's about 110 degrees, and so the polarity that results is not a super strong one, but nonetheless it is still there. Ethers have a lower boiling point in general than our other functional groups because of the lower polarity. However, if the two carbon chains on either side are huge, then the London forces increase, which then can give it a rather higher boiling point. Ethers are good for organic synthesis as well, because anytime we have a polar function to a molecule, it can attract different parts of other molecules and hence facilitate a chemical reaction. Other properties of ethers, they are good solvents. Because they are slightly polar, you can dissolve polar things, but depending on how long these carbon chains are on either side, they can also be very good solvents for organic molecules and non-polar solutes. Ethers are also anesthetics, which means they mess with pain receptors, and they use it in hospitals for putting you under for surgery. So some of the compounds they use to numb pain or to help you lose consciousness temporarily are actually ether molecules. Okay, the name of ethers, and you're gonna love this, the names of ethers end in ether. Whew. Let's do 3 quick examples, and you're only required to know how to name simple ethers. So to start, let's just name the one that I just drew up there. Why don't we put in the full structure, just for practice. Practice recognizing full structures. I'm going to draw a little angle in the middle, just to again convey the idea that ethers are not linear, a little bit bent. And let's draw the 2 remaining carbons, and of course they are attached to hydrogens, so all carbons have 4 bonds total. All right. The way that we name ethers goes like this. We look at the stuff that's flanking on either side of the oxygen, and we name those separately. So here is one flanking feature, and here is the other flanking feature. The first one, this one, is a methyl, and this one is an ethyl. We're going to name each of those things separately, and we're going to name them in alphabetical order. So the first one we're going to name is this group here, which is a 2 carbon strong chain. That's an ethyl. Okay, ethyl. And then the second feature is that methyl group on the side, methyl. And to finish, we just write the word ether. Ethyl, methyl, ether. 3 words. Boom. Done. Let's do another one. Here we go. Sometimes you see methyl groups, CH3, written as H3C, and it's done because in the structure, it's more comfortable that we join the line, the bond here, to the carbon and not the H's. So a lot of times when methyl groups are written on the left side, you'll see the structure is being flipped as H3C instead of CH3. Okay, in this case we have 2 methyl groups on either side. They are equal in size. Whenever we have 2 parts that are equal, we use the prefixes di, tri, and tetra, so forth. In this case, this is 2 of them, so this is dimethyl ether, dimethyl ether. let's go back to our line diagrams. Look at that, it's a happy face. Aha! Oh, the happiest of all molecules here. We have two ethyls. We have a carbon here and a carbon there. There's two carbons on either side of the oxygen. This is simply called diethyl ether. And we're done. Wasn't that easy? Oh, that's such a gift. Goo out.